Hello folks, Larry here again with Curio Mechanics. In today's video I'm going to give you a short overview of cassette tapes and some of the basics of keeping your tape player running well. With the resurgence of retro music collection, a lot of people are experiencing cassette tapes for the first time. And for some of us, it's fun to revisit some old favorites that are laying around the stereo once in a while. Because the tape technology records in a virtually continuous movement, it is considered an analog format. In brief, it works by moving the tape medium over a head that can either create an electric signal for recording or read the magnetic image on a tape for playback. The tape itself is coated with a thin layer of very small metallic particles and a substance used to hold these particles on the tape called binder. As cassettes evolved, there were several different formulations of particles and binders used to try to improve the quality and longevity of the tape. This led to 4 major tape types. They are referred to by the numbers 1 through 4. 1 is the easiest to record on and the most universal. If you buy a newly made tape today, it is almost guaranteed to be a Type 1. The number 3 was a very short-lived type that didn't really catch on, so most recorders only offer a setting for 1, 2, or 4. Types 2 and 4 use a different mix of magnetic particles, and generically Type 2 are called chrome tapes, and Type 4 are called metal tapes. This refers to the type of material used to record the magnetic material used on the tape to capture the magnetic signals. Type 2 and 4 tapes also require more power being sent to the record head to create the proper signals. The tapes themselves incorporate a notch system on the top to tell a player that is equipped to read these notches what type of tape is loaded so it can adjust itself accordingly. The higher numbered tapes offer a broader range of frequencies that they can record and mostly affect the higher frequency limit. If you check the specs of a player, they will almost always be stated on the highest number the player supports to show the greatest performance. A good set of specs will break down the result by tape types. The frequency range of a decent player will be around 60 Hz on the low end to about 13 kHz on the top end, with some getting better than this and several getting worse. Tape players made today don't use the same components that were sourced in the heyday of tape machines, so they generally have worse performance than a vintage machine. That leads me to the next thing to touch on. A tape player or recorder is a mechanical device and needs some love and care to keep it running and sounding well. The parts that pick up and record the magnetic signals are called heads. The tape is moved across the heads by being pinched between 2 rollers called the capstan and pinch roller. The capstan is usually what is actually being driven by the motor, and the pinch roller just goes along for the ride. This assembly is critical to the proper motion of the tape. When the rollers get dirty or misshapen, the results are usually that your tape sounds like it's playing underwater. This is very noticeable and can completely ruin your listening experience. The good news is that these are pretty easy to clean yourself. On most decks, you can just open the cassette door and see the rollers on either side of the heads. On a machine that features auto reverse, you'll see 2 sets of rollers. The system pulls the tape through the transport area, so the rollers for each side are after the heads depending on the tape direction. Auto reverse players work by actually running backwards for the reverse side. If your machine gets hungry and eats a tape, it's almost always caused by a problem with the rollers or drive not working together in concert as they should. The reason these rollers get fouled is usually because the binder used on the tape leaves behind a little residue when it goes through the tape transport. On my reel-to-reel system, which used even more primitive formulations, Some people will actually throw their tapes in the oven to help re-glue the glue, which is making the binder so it's more sticky. The tendency of a tape to leave a bit of itself on the rollers is called shedding. There are various ways to clean these rollers, but the way I do it is to use 90% rubbing alcohol on the metal side and a 50-50 mix of dish soap and water on the rubber tires. You can use a cotton swab dipped in a little bit and just gently rub the surfaces. If you get really aggressive, you can put the rollers out of round, which will permanently affect the way they sound. You'll get a repeating fast or slow waver to your playback. Just imagine how it would feel to drive on a square bottom tire to get the idea. It's also good to occasionally play your machine to keep the rollers from stopping in the same spot too long and potentially getting a dent in them. That goes for the internals as well. Some machines use rubber tires on the inside to transfer the power from the motor to the drive areas. The other type of kinetic transfers, the most common, is drive belts. These belts are probably one of the biggest causes of machine failure. They get gummy and deteriorate over time. They will need replacement over the total life of the machine. They can also stretch and either fall off or rotate weird given enough use or time. While they're usually meant to be changed, some player designs make it a feat of engineering to even see or get to. The personal portable models are probably the most varied in that aspect. Some are great, some are a real pain. In either case, it's best to take a look at a service manual to get an idea of what you can potentially face if you're considering buying a new machine. I've changed quite a few belts, and replacements are pretty easy to find, so it's not something to be afraid of. But again, be aware that some can be nearly impossible, and because they are the main connection to the motor, if they fail, your deck is kaput. Speaking of drive mechanisms, another quick thing to touch on is the fact that most machines have some sort of speed adjustment for the motor. If we replace the belts with another belt that isn't the exact same thickness, it can affect the speed of playback and might need to be tweaked. For most machines, this is as simple as finding an adjustment, usually a screw or a potentiometer, and turning it up or down to get the right speed. The correct way to do this is to use a calibrated tape that has a specific frequency recorded on it, and then measure the frequency as it's played back and adjust until it's exactly the right speed. As this is not something most people have laying around, you can usually get by with playing a tape you're really familiar with and setting it by ear. Another note on the subject of speed: almost all decks have a natural tendency to wander on their own during playback. The measurement of this tendency is called wow and flutter. It can either run fast, slow, or drift around while it's playing or recording. There are almost no machines made that are immune, but a good quality machine will be imperceptibly low to the human ear. New machines are probably an order of magnitude more sloppy than the machines that were made in the glory days, but hopefully good enough not to be too annoying. The benefit of any digital media is that it isn't subject to these mechanical fluctuations and offers a controlled speed by nature. The other thing I'd say, just to tick off the collectors, is that while analog recordings are considered continuous recordings, the recording head does actually have a bias frequency which will still cause quantization. What this means in practical terms is that the recording head still turns off and on during use, but it just does it fast enough to where we don't notice. People who don't like digital playback, their biggest complaint usually is that it also turns on and off in discrete steps. This is called quantization. I'll leave the analog versus technical discussion alone, but wanted to point out that on a technical level and today's technology, the two are closer to each other than some would like to admit. So that's a short rundown of what makes cassette tapes tick. For a lot of people, they can offer a lot of enjoyment, and to that I'd say great, you do you, like what you like. Even though the format does have its drawbacks, it's also a big part of the commercial music history. For a couple of decades, it's how we bought music, and it gave the turntable a real hard time on the market. I hope you enjoyed this jaunt down the dusty roads of old music formats. If you're new to the channel, please consider subscribing and joining the Patreon channel. Whatever you choose to do, though, I hope you enjoy your day.